You are recording.
Thank you, sir. All right. Welcome to Alg1 class. I don't know who's here, who's not here, but we're going to get started. I do know 3 people who's here. I don't know if we have Anna with us today, nor do I know if we have Miss Rebecca with us today. And I think Miss Rebecca is trying to join us now. No. Anna's trying to join us. I got to get all these names. I see this name. It could mean that. Oh, my variables straight. All right. So, a couple housekeeping items while we're all paying attention. Review item number 1. Please make sure that when you turn in a homework assignment, whether you are turning it in via an online process or if you are present and you hand me a hard copy, that you write your name at the top of each paper, and also that you write the assignment at the top of your paper. Please do that for me. That way I know who to give 100% to, okay? So make sure you do those things. Secondly, via our online friends, we had a little bit of a hiccup on Friday. And hey, if you're going to have a hiccup, why not do it on Friday? Why not? We could do it on Monday, but we did it on Friday. And the main hiccup was that we weren't able to record the lesson on subtraction. Wow. And it was a hard one, I tell you. Very, very difficult, very involved lesson. If you have any questions about that lesson, you were not present, nor is there a recording of that lesson, you should ask now. Anybody hear anything? No questions. All right. The only thing you missed was a great time, and you won't be able to review it on Easy Talks Review. By the way, I got a lot of BTWs today. If you do wish to review this lesson as being presented, it's being recorded and probably will be uploaded to a YouTube video site to be announced at some time, not now. I don't know where he's going to put the video that I'm now smiling at. But that video will be uploaded somewhere, okay? By the way, friends, that's true for whether you are sitting presently so that I can touch you, or whether you're online, you may view those videos, okay, if they're there. Does anybody have a question about that? Sir, go get some paper now. All right. So those are our housekeeping items for today. Next set of, does anybody have any housekeeping type questions? Like, what are we doing? Where are we going? I don't know. Is this Algebra 1 class? How am I supposed to turn in homework? Any of those kinds of questions, what I call housekeeping questions? Anybody? All right. Next question. Do you have any questions regarding the homework assignment that is due today? Do you have any questions regarding the homework assignment that is due for today? And that homework assignment that is due today, assigned on Freitag, you were to do the lesson on subtraction, sets 1 and 3, which may be found on pages 13, 14, 15, and I think probably 16 of Harold Jacobs' textbook, Elementary Algebra. Anybody have a question over those problems?
Man, I just had to fake words.
All right, no questions? All right, online friends, I think a lot of you have already turned your homework assignment in. Thank you. I'll take this sheet here and this sheet here. Very good. Life is very good. Algebra. I should have chosen different colors, but I didn't. I chose white. So, back to a housekeeping item, which kind of helps introduce the lesson for today. What we're doing right now in Harold Jacobs Elementary Algebra is thinking through basic operations. What's an operation? In mathematics, it does not mean that you are cutting anything. It means that you are adding, subtracting, multiplying, or dividing. So we're doing basic operations. That's what we're covering. And most of this basic operation stuff, adding, subtracting, multiplying, dividing. Most of this is review for you. And that's why if you missed a video or you missed class, you're like, I don't care, because I know how to do this. I've been doing this for a long time. One of the other things that I'm trying to do for you is trying to couch this information in a way that will be beneficial as we proceed on in algebra. So I don't know if I've been successful at that or not, whether I will be, but that's what I'm trying to do. I will give you a little insight. I'm not a prophet, but because I've taught this algebra class before, let me tell you something. Most students do very, 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 very exponentially very, very well through the first chapters of review, because it's adding, subtracting, multiplying, dividing, easy peasy stuff. Okay? Then I don't know what lesson it will be for you, but sometimes, usually around second quarter, or either second quarter into third quarter, you hit the elementary algebra Harold Jacobs wall, and it hurts. And all of a sudden, your average on homework assignments, if you've been averaging 95 plus, goes down 10% or goes down 15%. All right? Here is one way to stay on top of that. Even though these lessons are very, very easy, do your lessons well and pay attention. And hopefully it'll build a great foundation for when we have to start climbing the hill, so to speak. It's a little tougher. And basically what happens is you have new information that you have not heard in a previous grades, preschool through 8 math class. When that new information starts coming fast and furious, it causes a little bog down. So, be diligent, enjoy these days in preparation for the days to come. Today's topic is, we've already discussed adding, subtracting, multiplying. That's today, that's Monday's topic. And what happens is we keep talking about these topics, so that if you look at the lesson plan, tomorrow we talk about division. On Wednesday, we talk about raising to a power. So here's Tuesday. And then we talk about raising something to a power. So 2 raised to the power of 2, raising to power. That is lesson number 5, which we will attempt on Wednesday. On Thursday, this is Wednesday's lesson. On Thursday, we're going to talk about some unique numbers, namely 0 and 1. And we'll introduce the history of 0. 0 has a history. It was named in time and had status in time among mathematicians. And for a time, as a numeral, as a digit, it has no history. So it has very little history. And then we'll talk about on Friday. Stay tuned for Friday, because what happens on Friday is we're going to put a lot of this together into one lesson. And it'll be kind of a review where we're looking at several things happening. Right now you've been given primarily, when we had addition problems, you've been given addition problems. You've been given subtraction problems, you've had subtraction problems. You've had the multiplication lesson, you're going to have multiplication problems, and so forth. And then the one thing that sometimes confuses math students is, I'm okay as long as you give me 20 problems on the topic we just discussed. But what happens when you give me 20 problems with an admixture of the various topics that we've discussed, well, you're going to do fine. You're going to do absolutely fine. And that's the way Harold Jacobs works, the way a lot of math text works, and you can expect that throughout Harold Jacobs' book. All right. Today's fun, multiplication. We're going to have you think about multiplication in a couple different ways. I'm going to write it in red. The first thing that I need to say about multiplication is that I hope all of you have your multiplication tables memorized through at least 10, and preferably through 12. So that you should know that 11 times 11 is what? Sir? 121. All right? Or that 9 times 6 is? 54. 11 times 7 is? Lillian?
77.
77. 77. All right? So you should know that. That goes without being said. Let me also say at this point that this is where a lot of students want to use calculators. So let's talk about calculators in math class. May you use a calculator in math class? This is my simple answer. If you think it will help you. Those that have had my classes know that sometimes it's helpful and then sometimes it's not very helpful. But if you think a calculator will help you, go for it. So I don't have a strong preference about using a calculator or whether you don't. Do you have to have one to do these problems? No. Might you make the same kinds of, different kinds of mistakes, but might you make mistakes with a calculator? Sure. Can you really check your answers with a calculator? Sometimes. So we don't want to over-rely on them because sometimes they're helpful, and the truth is sometimes they're not. Sometimes they're more confusing. And I've seen people write the correct answer before by figuring it out on a sheet of paper, check it with a calculator, change their answer, and the reason they change is because of data input problem. So they punched in the wrong numbers, and all of a sudden they had a different answer. They erased their correct answer, put incorrect answers. But so if you think it will help you, you may. Do you need one? No. So there's the lesson on, and that's true throughout this class. I do think that when we get to raising to a power, that sometimes that can be helpful to have a calculator. But then again, you have to know how to use your calculator. And this class is not about how to use a calculator, so you'll have to figure that out on your own. As a general rule, we won't have a lesson on how to use a calculator. All right. So multiplication, two general ways of looking at this. One is a quick way to do addition. All right? That's probably the simplest. So that when you were learning your algebra table, or your algebra, your multiplication tables, you thought and probably introduced to you, if you are a Saxon math individual, was introduced to you in such a way that you are finding a faster way to do addition. Pause. It is faster than addition if you have your multiplication tables memorized. It is faster than addition if you know how to do multiple digit multiplication. Otherwise, it can be a lot longer. If you don't know those things, you have a lot of potential for mistake. But one way is a quick way to do addition. The other way that Harold's going to introduce to you is using it in a geometric way, with figures. And we'll talk about that. So two basic ways that you're going to be quizzed and made to think about multiplication that you're going to use throughout this textbook, okay? Quick way to do addition, geometric way. Let's take each of these. Quick way to do addition. I could ask you, what is 4 plus 4 plus 4 plus 4 plus 4 plus 4? And you could do this. You could say 4 plus 4 is 8, plus 4 is 12, plus 4 is 16, plus 4 is 20, plus 4 is 24. Or, realizing that you have the same number, 4, being added together 6 times, you could also write 4, actually you'd write it, Harold wants you to learn it this way. You have 6 4s. You have 6 4s. So 6 4s, 6 times 4, you have your multiplication tables memorized. 6 times 4 is 24. Right? So becomes another way to quickly figure out what happens if you have 6 4s. A way to write this in Harold form is this. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Because Harold's always losing his marbles and he's always trying to write them down on a sheet of paper. Okay? And so we're always trying to help Harold find his marbles. So this says 6 4s, by the way. It does not say 4 6s. It says 6 4s, and I want you to understand the difference. It says 6 4s. There are 4, and there are 6 of these. 1, 2, 3, 4, 5, 6. Those are 6 4s. If I were to say 4 6s, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. I have 4 6s. Now it just so happens that 6 4s and 4 6s both have a total of how many? Yeah, you have a total number of marbles of 24. Whether you have 6 4s or 4 6s, this also equals 24. All right? So in multiplication, you can have 6 times 4 and 4 times 6 and still get 24. You can switch them. Does that work in subtraction that you had for yesterday? Is 6 minus 4 the same thing as 4 minus 6? No. No. It's true here. It's built upon addition. Is it true in addition? If I have 4 plus 4 plus 4 plus 4 plus 4 plus 6 times, and if I have 6 plus 6 plus 6 plus 6 4 times, well, I end up with 24. Does it matter how in addition, does it matter what order they're in if I take the sum? Is 5 plus 6 the same as 6 plus 5? Yes, it's the same. So, multiplication built upon addition, the same rules apply. You can reverse them and you'll get the same exact total. All right? Marble-wise, they look different. They look different. This is 6 times 4, and this is 4 times 6. All right. Now, in addition to marbles and a quick way to do addition, there's also a geometric way. And that geometric way borrows right away from what you know about rectangles and squares. Squares and rectangles. In other words, you have learned that if you have a square, here's a square. If you have a square, a rectangle, if you take the base times the height, whoops, you find the area of the square. Or the other way is, if I have a box, if I have 2 boxes high, how many boxes are there? 2 times 3 is 6, right? 2 times 3 is 6. So there's also the geometric way of thinking about that. And Harold's going to quiz you on both. Now, one last little thing, and that is on a geometric way, what if I have 3 high, but I don't know how many across? How can I represent that? And how can I represent that? 3 and x, what is that? Yes, sir.
3x.
Yeah, there's 2 ways I can say. I can say 3, and there's a couple different ways that we can write times. I can write 3 times x. I can write, because the times and the x look very similar. Are you able to see me? Let me focus. Is it focusing? A little better. I can write 3 times x, but because the times, and I'm sorry this red doesn't appear to be showing up very well, I can write 3 times x. I can write 3 solid dot x. This means times in math, solid dot. It's not a decimal, it's in between, the 3, halfway in between. Right in the middle, 3 solid dot. Okay? I can also write 3 in parentheses and x in parentheses. All of these say 3 times x. I can also write this, 3x, nothing in between them. So all of these say that. This says that says this says, okay, you get the point. 3x, parentheses, using a solid dot, using a times sign. As a general rule, we don't use the times sign very often in algebra. What we do use a lot of is a solid dot, and we also use a lot of parentheses. We also express answers without either. So in the course of this class, you will see these 3 primarily used, and you'll see these 2 being especially used in your math lesson. All right? Okay. Turn with me, please, to page 19 in your textbook. And let's look at set 2. We'll do some problems. These are exactly like the problem set 3. Your homework assignment is to do set 1 and set 3. I'm going to pause at this moment. I'm going to tell you that if you think you can plug and chug and fly through these problems and you'd rather use the last 8 minutes of this class or so to do your homework, you may. Otherwise, I'm going to work through some of these problems as examples to show you how to do them. So you have what's called freedom of choice here. And who knows, you may have already started working on your homework assignment anyway. But you can make that choice. If you want to follow along, I'll show you how to do some of these problems as examples for the problems that you'll have due for Tuesday. Okay? So, here we go. Some example problems. Looking at set number 2, number 11. Harold says, draw figures as indicated. Then he says, hey, a figure with circles. I call them marbles. Okay? Just so we have clear communication. A figure with circles or marbles. To show that 4, see the center dot there, that means times 3, and 3, see the center dot, 4 are the same number. What are we going to do? We have 4 3s. This says 4 3s. And this says 3 4s. So, if I want 3s, 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. That's 4 3s. Or 3 4s. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. That's 3 fours. See the difference between 4 threes and 3 fours in Harold's marble theory. Poor Harold, if we ever find him, we're going to give him some of his marbles back, okay? I'd like to invite him to class someday. He's probably busy writing textbooks or something, I don't know. 4 threes, 3 fours, got it? Now, look at letter B. A figure with boxes to illustrate 5x, 5 times x, if each box represents x. Each box represents x. 5x, Harold says, if each box, here's a box, that's x. But that's only 1x. Here's another box, that's 2 x's. Here's another box, that's, oops, got excited. 3 x's. Here's another box, that's 4 x's. Here's another box, that's 5 x's. Stop. Represent 5x in boxes if each box is x. So they could be written as separate boxes. Could you also do this? 1, 2, 3, 4. Yes, you may. Okay. Yes, you may. Yes, you may. Look at the next one. C. A rectangle divided into squares to illustrate 2 times 7. Okay. A rectangle. Let's get a rectangle up here. 2 minus 1, 2, 3, 4, 6, 7. Right? 2, 7. That's it. It's 2 deep. It's 7 across. 2 times 7. Anybody have a question about doing these kinds of problems? Now look at problem number 12. A. One of the words that we use in multiplication is the product. So the product of 5 and 6. You are to write a number or an expression. Or. So there's 2 things you could write down for letter A. What might you write down? On it. I think Anna's trying to tell me, can I hear her? And Anna, do I have to be honest? I usually don't tell lies, so I have to be honest. No, I can't.
I can hear her. Sometimes.
Did you hear me then? Because if you did, I was whispering, so. Okay, so Anna and I will have to visit about why you can hear her, Lillian, and why I can't. Can you hear her? Can you hear her? No. All right. We'll have to figure that out. As long as you can hear me, we're good for now, but we'll have to figure out the communicatio, okay? So let's keep cruising. The product of 5 and 6, Lillian, help us out. What did she say and you say also?
30.
Okay, so you could write down 30. You could also write 5.6 or 5 times 6 or 5 parentheses 6. All those say 30. Look at letter C, 12C, the product of 5 and x. 5x. Easiest way to write that, simplest way to write that. Understand those? Okay, skip with me to set 13. Look at letter C. You are to write each of those, write a multiplication problem equivalent to each of the following addition problems. So C, x plus x plus x plus x plus x gives me what? What can I write down as a multiplication problem?
5x.
Oh, 5x. Okay. Now, look at letter D. 7 plus 7 plus dot, 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 3 dots plus 7. 11 of them. How can I write that as a multiplication problem? Well, there's 7. And how many, if we go this way, there are 11 sevens, right? There are 11 sevens, 11 times 7. Look at letter E. How many sevens are there? You could say x times 7, or the easiest way to write that is 7x. Either way would be fine. Everybody see that? Look at letter F. Y plus y plus y plus dot, dot, dot plus y. And there are x of them. How can I write that as a multiplication problem? Well, I have y's. And how many y's do I have? I have x of them. I have xy. X times y. Or you could write x dot y, or x times y, or x parentheses, parentheses, so forth. Now, Harold switches them around. So he goes from addition to multiplication, but then in the same problem, look further down the bottom of page 19, right-hand column, write an addition problem equivalent to each of the following multiplication problems. So now he's going the other way. So, 3 17s. 17 plus 17 plus 17. Everybody got that? 4 x's. X plus x plus x plus x. See, if you learn to read it like that, 4 times x, 4 x's, it'll help you think through the addition statement. 4 x's. Look at this one. Y2s. Letter I. Now, it's best if you follow the example of stating what's being added, 2 plus 2 plus dot, dot, dot. These are not multiplication dots. These are like and on kinds of dots. And on kinds of dots. These are not multiplication dots. Plus 2, and how many of them are we going to have? How many of them? Somebody?
Why? Why?
Why? Well, because it's the problem. It's problem letter I. And it says to write the following multiplication problems as an addition problem. That's why. So what's the answer?
No. Y2s.
Why 2? Well, it's 2's because...
Why is the variable?
Why is it? Well, that's just what Harold gave us. I'm sorry, I'm being a smart aleck.
No. As the variable.
I want to see if I can mess with you from like 1,000 miles away. And I succeeded, so I'm going to have a great day. Yeah, you're right. Just like that. Okay? So that's how you would write letter A. Z is pretty easy too. I have Z plus dot, dot, dot plus Z. And how many Z's do I have? I have that letter Y of them. Why? I don't know.
Why not?
All right. Questions about that? Okay, I've got just a couple minutes, 1 minute left. 14 is basic base times height problems, right? So look at letter A. You are to write them as the area. 7 and 8 is 56. 10 and x is 10x. X and y is xy. X and x is x times x. All right, and then he gives you some word problems on using multiplication. Got it?
You got it.
So your assignment is to do sets 1 and 3, pages 19 through 22 for tomorrow.
Wave at Lillian. Wave at Lillian.
Hasta la vista.
Wow.
Very well.
Response.
Hi.
And she
Oh,
said
hi.
hi, and she's waving at us too.
If the rest most of your classes don't go well today. I hope that Algebra 1 was the best class of the day.
Julia.
Hi, Julia.
Whose bread is this?
David.
Who do you think?
David's. Obviously.
David, you're.
Anything.
David is.
David.
Okay, I cut her off. That's fun. Not that I want to cut Lillian off, unless you're hard. But it is fun to cut people off. Rakita, have you ever cut anyone off before? Have you ever cut anyone off before? Never? You should try it sometime. It's kind of fun. You just turn them off. Just do it.
It's your fault.
All right.
I told you late. You have to tell her. I have a conflict.
We are being recorded, by the way. Anything you say can and will be held against you in a court of law. Did I mention that we are being recorded? Anything you say can and will be held against you in a court of law. I wish to make that known. Not that any of you are doing anything illegal that I can tell. Lance, you look like you're pretty legal today. All right, I just want you to know that what you say can and will be held against you in a court of law. Wow, I am just realizing that some of you have very long hair. I saw about 100 people yesterday with some of the shortest hair I've ever seen in my life. It was kind of scary. It was. It was very scary. I don't remember whether I had nightmares about it or not, but I may have, because I do dream a lot.
Was one of them your son?
I don't know, because I dropped my son off at college and I couldn't recognize him the rest of the day. So it may have been. People kept hugging him and giving him kisses. I guess that was my son. It was somebody with very short hair. Oh! Easy talking. Oh, no, we're not easy talking on Algebra 2 right now. Hey, would somebody turn that thing off, please? I love you, camera, but we're going to turn you off. Bye!